In this tutorial, we are going to talk about web testing best practices using C#. However, today's modern web applications are much more complicated, and creating a good testing framework is much harder than simply writing a few functional Selenium tests.
Hence, we are going to create a testing framework using a number of different testing techniques.
Of course, we're going to test on desktop and the most popular browsers and operating systems there. We're also going to test on real mobile devices with Android and iOS. We're also going to do functional testing on Android and iOS emulators. And we're also going to do visual testing to ensure amazing responsive design of our web app. We're going to run our entire framework in the Sauce Labs cloud, which means that we are automatically going to get video and text logs. I'm super excited to show you everything that I've got. So let's go. So before we actually do a deep dive into the code, let's go ahead and take a look at what you're going to be able to do at the end of this presentation. So if we pull up our PowerShell window and run all of our tests using .NET Test, that's going to start executing all of the tests that we've written in this best practices web testing framework. We can come over here to our Sauce Labs UI to see exactly what's going on. So if I scroll down a bit, what we can see is we have about 61 devices being utilized, now up to 68, that are all running in parallel, doing different types of testing from desktop all the way to mobile and across multiple different browsers and resolutions. We can see all of those running here. We can see visual tests running. We can see different types of functional tests being executed on different kinds of browsers and operating systems here. Because it runs in Sauce Labs, what we get automatically with every single test is a video and a bunch of logs. So here is an example of what a test looks like on Safari and Mac. We obviously get a video of this test being executed. So here, for example, is a problem user that is trying to log in. Over here on the right hand side, we get all of these commands that are able to help us debug our tests. This all happens automatically without needing to do any extra work. Here's an example of another test. This one runs on an actual real device. So if we pull this up, you can see that here we're spinning up an actual real iPhone device, and our web application is going to be tested there. And we have similar kind of functionality happening on emulators and simulators. In this case, we have an Android device. And so in here, we can see an Android device is being pulled up. And this test just checks that this login page opened, again with all of the same similar commands that every single test in Sauce Labs gets. Besides all the functional testing that happen, it's really important in a web testing strategy to do visual testing as well, because we have to check the responsive nature of our application. And so the visual nature of our application is here in Screener. You can see that we executed just 10 tests with all the different states. We can come here and review all of the different states. Up here we can see the resolution and the device on which every single page was captured. Here we can see that here's an iPhone X, here's a Galaxy Note 10, here's a Pixel XL, and we were capturing snapshots for the different types of pages. So this is our login page, validating that everything looks exactly as it should. And in this case, this passed successfully because over here on the left-hand side, there was no mismatch between. And so we can look at this for login pages, products page, and many other pages on many different browsers, operating systems, and devices. So we can come back here to Sauce Labs at our test insights and take a look at exactly the breakdown of all the tests that kind of just ran. You can see in the last hour everything that I've executed. You can see how many tests were executed, 165 tests ran, 163 passed, 2 failed. We can see a breakdown by the different browsers that we used, by the operating systems that we used, framework, and all of the types of devices that we used as well. And then if we come back to our results, we can take a look and see here that we executed 176 tests in 2 minutes and 20 seconds. So overall, a really fast feedback in terms of our application quality and figuring out exactly what's going on there. So before we actually dive into the code and figure out how to implement all of that functionality, we need to look at our application and understand exactly how it works. And also we need to think about a test strategy that we're going to apply to get the maximum amount of coverage for our application. So here is the application under test, saucedemo.com. It's a relatively simple web application that is similar to any kind of e-commerce platform. You can log in here with different kinds of users. Just be sure you don't share this password with anybody. It's super secret. Once you're inside of the application, you can add different items to a cart. You can remove those items from a cart as well. Once an item has been added to a cart, you can proceed through the checkout process by filling in this information, and then when you click finish, you are successfully checked out, and that is how the application makes money, right? Similar to an Amazon or any kind of e-commerce application. It is coded in one of the most popular front-end frameworks, React. And so it's similar to most modern web applications that we're going to see in today's time. So what is the testing strategy that we're actually going to apply for this application? So in our repo here, we have a README that describes the testing approach that we're going to take to test our application. So in today's modern day and age, especially with the applications the way they are and the technology that we have, functional web testing is not the only testing that is part of a strategy any longer. It cannot be if we want to move fast, if we want to ensure the optimal amount of coverage, if we want to ensure that our users are satisfied and our applications are making money. There is much more to a testing strategy than just browser testing. And so in our application, we are going to be covering all the coverage risks by doing browser testing on desktop and mobile, which is a huge amount of traffic in today's day and age. We're going to be doing visual testing, and then in this tutorial, it's not going to be integrated into a CI/CD pipeline, but it's something very important to think about as we're designing our framework. And then, of course, it's going to use the latest cloud grid infrastructure to make it easy for us to run in parallel, be scalable, and also get a bunch of cool features like videos and logs. So here's our testing strategy for our application. One of the very first requirements is that every web page of the app has to look correct on desktop. How we do that is with a visual test, and we're going to do that using Selenium and Screener.io. These visual tests also ensure one other piece of functionality for us, which we used to do back in the day with Selenium, but now we don't need to do it with Selenium anymore because we have visual tests with Screener, for example, is rendering of the applications. A visual test not only ensures that our application looks correct, but it also obviously ensures that it renders. And then the same thing goes along the lines on mobile as well, especially having a responsive web application. It's extremely important to ensure that it looks correct on all the different popular browsers, operating systems, Android, iOS, and so on. And we're going to do the same thing, but instead we're going to use Appium with Screen.io. Next, we're going to ensure that a user can successfully check out on a desktop. there are many different kinds of functional flows that we can test on our application. However, the most important one in our application, the one that makes money, is ensuring that our user can successfully go through the entire checkout journey. And so that's going to be a simple functional web test using Selenium. We're not really going to test any other functionality besides that with Selenium, because it's not really relevant, and we can usually test it with other means, especially with like component tests or unit tests inside of our React application. And we'll do the same thing on mobile. Now, this test is actually redundant of this functional desktop test because it's a web application. And so the functionality of that web application is not going to change when you go from desktop to a mobile device. It's the same code, just simply on a different resolution. However, because it's relatively simple to do it with a technology like Sauce Labs, we're going to do the same test with Appium as well. Again, just because it's relatively simple to do and it's critical for our application. So we're going to test it there. We can also get into non-functional testing of our application, such as front-end performance testing and ensuring that our application comes up in a reasonable amount of time for our end user to have a wonderful experience. We're not going to do that in this repository, but it is something that to strongly consider. If we were to do that, we can easily do that with Selenium and Sauce Labs. As I mentioned here, we are not implementing a CI/CD strategy. However, it's really important to consider that as we move forward with the test code. And so we want to ensure that on every commit, all our tests execute in under 5 minutes. The reason for that is slow feedback makes it hard to iterate. And so our code will be set up to make this possible, even though we're not going to implement it here. And then we can continue taking our application to the next level by even ensuring that it's secure and accessible. Not covered in this code base. However, it's something to consider for an overall more comprehensive test strategy. Okay, so with all of that said, let's finally jump into the code and check out how to make all of this possible. So let's start at a higher level and explore the solution architecture of our best practices project here, written using .NET 5. So the very important section of this repository are the tests, right? This is the requirements that we're going to be meeting with our testing. Those tests are broken down into two types. There are desktop tests. The desktop tests are functional browser tests that happen. They kind of look like this. And then we also have visual tests. Those are going to be rendering our application and ensuring that it looks correct on desktop and mobile resolutions. Next, we have a mobile test section. Those obviously include Android and iOS. And for each of those test types, there are emulator tests, which are really good for running in massive parallel and doing a bunch of functional testing at the same time. And then we have real device tests as well. Those are really wonderful for making sure that your application behaves as it should on an actual device, not an emulator simulator. It has all of the real production capabilities of a device that you want to target. And that is the same for both Android and iOS. With those tests, we have our page objects. This is a web application that we are testing. So our web application is represented using page objects. So there are mobile page objects. We have them for Android and iOS. And there are desktop page objects, which represent the desktop version of the application. Let's start by looking at a desktop test. The most common type of test probably to the majority of us, but it has a number of very important factors that we have to take into consideration when designing web best practices. So here are all of the technologies that we're using. We've decided to pick NUnit framework as our test runner. And the reason for that is because NUnit actually allows us to run our test classes in a data-driven manner, which is very useful when you're trying to do cross-browser parallelization. On the other hand, for example, MS Test does not have class-level data-driven capabilities. It does method-level data-driven capabilities, and so that's why we went with NUnit. And that brings us to this very important point of how to do data-driven testing across this class. And so here we can see that we have a test fixture source. And in that test fixture source, we are supplying the data for popular desktop combinations. Let me show you exactly what that looks like. So if we navigate to this, it's an IEnumerable, contains a number of different popular desktop combinations, obviously can be tailored based on the needs of your web application. Every single one of these rows is going to return a new class, which is then going to run a different test. And so here you can see, for example, we have a Mac. Here we have a Chrome browser. And here we have an Edge browser. These variables here are coming up here from the top. So you can see we have Safari options configured, or Chrome options, or Edge options, depending on your needs, with default values set accordingly. If you don't want to use defaults, you can of course override them here with whatever values you are passing in. Here is an example of doing the same thing, but with one version back. Nowadays, most of the browsers stay relatively up to date, where you're either on the latest or maybe one version behind. And so that's why we have testing of one version back as well on Safari, Chrome, and Edge. And down here is just a repetition created simply to show the power of parallelization and how many different types of tests we can run at the same time. Again, keep in mind that every single one of these rows means a brand new class that's going to run a test method. And so if we run this in parallel, it'll be able to run every single one of these in parallel at the same time. Which brings me, that's here, this parallelizable attribute that comes from NUnit as well. In our actual desktop test class, as every single test class should, there is always a setup and a teardown. And so here, if we go into our web tests base, we can see there is a setup that will do anything before a test actually executes, and a teardown will do things after a test method executes. Both of these are critical, and as I mentioned, must be in every single test class. One of the very important things to always do is make sure that you are quitting your driver at the end of every session. That will tell the remote WebDriver to end the session. So here is how we are actually able to parameterize our desktop tests. You can see we have a constructor here that's taking 3 parameters. You can modify them based on your needs. However, I found that these tend to be the best for parameterization, where we're passing in a browser version, a platform name, and the browser options. These were the driver options that were coming in, Safari options, Chrome options, and so on. And as a result, we are setting the appropriate capabilities. Now, one thing worth mentioning here is that in today's day and age, cross-browser testing is not extremely necessary. Most of the browsers operate in a very similar manner. Chrome and Edge, for example, run on Chrome's browser engine. Safari has its own. So if you're going to be doing cross-browser testing, probably the best thing to do is to test on Safari and Chrome, and all the other browsers will most likely behave the same. It's actually very rare nowadays to find functional differences between the different browsers. Where you will find a lot of differences actually in visual testing, which we're going to cover next. And here are the actual tests and what they look like. The very first thing to note is the test name. The test name is very clear and tells us exactly what the test does. And so we know the application that we're working on. And so in this case, if we look at the test name, we know that this test validates that the login should work. If we look inside of the test, we can see the test is written in plain English. It's very easy for anybody looking at this code, whether you have seen C# code before or not. It's very easy to understand exactly what it's testing. The fact that we have a login page, we are visiting the login page, we are logging in, and then we are asserting that the product page is visible and that does not throw an exception. Our test methods should never have any kind of implementation details, because the test methods are meant to be requirements. And so the only reason that our test methods should ever be changing are when our requirements change. And so that means that as long as this flow continues to be the same, where we visit, log in, and assert that another page has come up, as long as that doesn't change, our test shouldn't change as well. And so we should not see anything in here related to element locators, anything related to creating SQL connections or opening up Excel files, or any of that kind of stuff. Let's actually run this test just to see what that would look like. So we can come here and run this test. Down here you can see other tests that are implemented. One talking about invalid credentials should fail, right? So in this case, we are asserting that there is an exception thrown because we should not be able to log in. And there are many other tests here. Now, while this test is running, the login test work, let's come back here to Sauce Labs. And what we're going to see if we scroll down is that there's a number, in fact, 36 tests running in parallel, and all of them are testing that login works. Of course, they're being done across different browsers and operating systems. That's coming from that test fixture source that we were able to set up. A bunch of them are already being finished. You can see this is again the power of parallelization. Parallelization is absolutely critical to any test automation effort. In fact, I say that it's impossible to succeed with a test automation effort without being able to run in parallel, because what we can see just happen is that our entire suite finished as fast as our slowest test. And so our tests are taking about 13 seconds here. This one took 17 seconds. So our entire test suite, if we come here and look at the builds that we just executed, which was this one, we executed 36 tests in 24 seconds. As previously we've talked about, every single test comes with a video playback. That just comes automatically simply by hooking into Sauce Labs. And we can see our test being executed here, and then we can have the logs to analyze if something went wrong. There's another very important component to these tests, and that's page objects. Let's tackle that next. So page objects are a very important concept in automated testing. They're basically a way for us to abstract out our HTML web pages into classes that then make reusability and maintainability drastically easier. And so in this case, what we can see is the fact that we have a login page, and the name of the class matches the page to which it relates to in HTML. So in this case, if we're looking at a login page, right, you might imagine that in our application, the login page is reflected to this. And so anything that we see here should be reflected in that class and nowhere else. So this page, you always have to think as an end user as well. And an end user comes here and interacts with the page. And so an end user for this, in this case, is able to log in, and that is pretty much it. And so we have to abstract this functionality into our methods of the page object. And so in this case, what you can see are the fact that this page object can visit the URL, which a user can do, and this page object is capable of logging in. And then of course there's a capability to check that the page is visible. You will see no other public methods that exist here that an end user is not able to get. There is this get performance method that exists here, but that is only for testing purposes in order for us to be able to figure out the performance of the page. However, we're not going to see any other kind of methods that allow us maybe to read a database or open a spreadsheet or modify a CSV file. And the reason for that is that a user never performs those behaviors, and so those behaviors should never leak into the tests. And the same thing goes with our locators. You will notice how there will be no public locators that can leak into the test as well. The reason for that is that a user doesn't come to our applications to find elements, click buttons, and type strings. They come to our applications to log in, to add an item to a cart, to check out. They perform flows. They perform flows, also known as behavior. They don't come to interact with the HTML pages. And so the HTML page interactions happen inside of the page object, and if those ever change, we go to a single place to update that behavior while our tests remain the same. So that was pretty much it for the desktop tests. Relatively simple, but overall a lot of very important concepts in bringing everything together to make it work exactly as it should. Now, let's move on to visual tests, which many individuals are not familiar still with this technology, and visual tests are extremely powerful at making sure that our applications look as they should, especially web applications in responsive modes. And they are extremely easy to write. And so here we can take a look at our visual test class. The setup is very similar to the desktop test. In fact, you'll notice the setup for all of the different types of tests continues to be very similar in terms of there's going to be a setup method and a teardown method in every class. And then there's going to be different kinds of configurations that are happening. And then the tests themselves are usually the most important part. In this case, one of the best use cases of cross-platform and cross-device parallelization is actually for visual testing. And so you can see we've implemented that here as before, but in this case, we are looking at popular visual resolutions. I'm going to go ahead and open that up, and you can see we are analyzing our application on multiple different resolutions to see how it looks on the devices that are relevant for us. And for that, that includes iPhone X, 1024p, 1080p, Pixel XL, and Galaxy Note 10 Plus. Of course, you can expand this to whatever coverage you need. And this is just taking in the Safari options object and the correct viewport size. We can then see the visual setup method here. It sets up source options as all classes here will. However, for visual testing, we also need to configure visual options, and that takes in those objects as well. And then it returns us a driver cleanup method, pretty much like every test method, every test class here has. And then here you can see is our constructor and how we set up our data-driven strategy, passing in the driver options, the viewport size, and the device name. That's exactly what we saw right here. And finally, the actual test, as I mentioned, visual testing is extremely easy to do, but insanely powerful. And it actually can replace a lot of the functional testing that we used to have to do. Visual testing can take its place instead. And so here you can see, here's our visual end-to-end flow. The easiest way to do visual tests is simply open up your application, decide which pages need to look good for the users, right? Not all the pages need to always be validated. Maybe a contact us form or some random pages that nobody ever visits don't need to be checked. However, all the pages that do need to be checked, you simply visit them one by one. And here you can see, right, we have our login page that we visit, and then we take a snapshot. We log in, take a snapshot of the products page, and so on and so forth. We can continue to do this through our entire application, capturing as many pages as we need. At the end, calling a visual and command that will give us back the results, and we assert that those results are not null. Let's run this. And while that runs, I'm going to quickly take you into what the take snapshot command looks like. It's a simple execute script command that performs the following operation, and it's getting the class name and putting in the name of the class, which corresponds to our page object. Let's go see our test running. If we come to screener.io, here we can see we have our test being executed. We have a project name called Sauce Demo C#, and in here our tests are being executed. You can see all the types of tests that are being executed right now and their configurations. The very first time that visual tests are executed, they are going to show up as new, and the reason for that is because the snapshots that have been taken have never been taken an action on, and so we need to manually decide whether we want those snapshots to be our new baselines that are going to be used for every future test execution, or maybe they don't match what we wanted them to look like, in which case we need to go back to the team, report the bugs, have those fixed, and then rerun the tests. We've previously already set many baselines here for our application, and so what we can see here is what it looks like when we actually finish execution. So you can see every single test executed on an iPhone X, right? We see our login page, products page. We can have many more pages show up here on a Galaxy Note 10 Plus, and so on and so forth. And up here you can see the exact configuration that was used. We can open each one up and we can see a comparison. On the left-hand side, we see the previously accepted. This is exactly what I just talked about, where when you initially execute your visual test, you set a baseline. We've said that this page on the left-hand side looks exactly as we want it to look, and so we accepted it as a baseline. On the right-hand side, we see the current version of the application. This is exactly what we just executed and the exact snapshot that was captured. And you can see that it matches exactly as we want it to look on the left-hand side. No visual differences were spotted by Screener, and so everything is okay. And we can continue to proceed through every single page like this, making sure that everything is looking as exactly as it should. And if it doesn't, Screener will point that out to us automatically. Whenever there are visual changes, I can show an example of that. Whenever there are visual changes, you'll see a build that kind of looks like this and shows that there were 4 changes. So we can see those kind of changes show up like this. You can see previously accepted versus current. You see that Screener highlights exactly what has changed. If you want to get into more details, we can see that there was a layout change and a style change. We can decide what we want to do with this change here, either by accepting it or rejecting it. If we reject it, it means that some changes need to be made before we set a new baseline. And here's what different kinds of changes can look like. And in this case, this is something very interesting to note. You can see that we've actually removed this trial expire header in this application. However, this is the only thing that Screener identified. It didn't identify this entire page shifting. And so the power, again, of the visual test, as you can see, is instead of opening up pages and validating that many different types of elements exist, we can now simply open a page, capture the snapshot, and know that it looks exactly as we want it to look, on different browsers, operating systems, and resolutions. Let's go ahead and talk about testing a web application on mobile devices. So let's take a look at some mobile tests. So mobile tests, we have Android and iOS, obviously. They're going to look extremely similar because this is a web application that we are testing. It doesn't matter that it's on a mobile device. It's still the same source code, just running in different resolutions on a different device. So those tests do look similar. However, if you're testing native applications, for example, it's very possible that your Android and iOS tests are relatively different because Android and iOS obviously have different functionality, and with native applications, that functionality certainly comes into play. Anyway, let's pull up our Emusim test here for Android to take a look at what that looks like. Now, one of the things to understand about emulators and simulators for mobile testing is that they are extremely scalable because they are just virtual devices that are being spun up on virtual machines. It's extremely easy to run many functional tests in parallel on emulators and simulators. So here you can see that we're continuing to follow our data-driven approach, running across multiple different browsers and operating systems. Again, keep in mind how much of this you want to do because we don't need to do this for every single functional test. Here you can see we're configuring popular Android simulators. If we take a look at those, you see it's following a similar pattern. And here we are only supplying the device that we want and the version of that device. We can have obviously many more different types of devices. Here, all this duplication is just again for showing the power of parallelization. The theme continues of having a setup and the teardown in every single test class. In this case, however, now because we're no longer working on desktop, we're going to be using Appium, and so we are going to be configuring Appium options. You can see how I've set those up here. And in our teardown, we're continuing to do similar of killing our tests and making sure that we are calling a driver.quit. We can quickly take a look what an Emusim base test looks like, which simply supplies a device name and a platform version. And then we have a constructor, which is where we're supplying those values that are coming in from our parameterized test. And we're using those not only for Android, but we're also using those for iOS. You can see that in the .NET environment, we require an Android driver for Android and an iOS driver for iOS, so it's important to keep those separate. And then here you can see we have a test. Now, this is a very simple test. It's a functional test. We don't really actually need to perform it on an Emusim device because this is simply just opening up a page. We already know that it renders correctly because we have visual tests. We even have some functional tests on a desktop. So there is absolutely no reason why this behavior would be any different on an emulator device. Instead, if we really wanted to touch this on mobile, what I would have done is have a end-to-end screen checkout test on a real device instead, and that would meet much more testing criteria. But again, this is just for demonstration purposes, and I wanted to show you what it looks like. You can see the pattern continues in terms of the test styles. The test name continues to imply exactly what the test is doing. We're using page objects. Tests don't let any implementation details seep through. If we want to take a look at what a mobile login page looks like, you can see that this is what it looks like. It's a login page. You can see it can do other behaviors such as navigating to a URL and so on and so forth. We can run this test and see what it's going to look like in Sauce Labs. Let's give it a run. We'll see 7 virtual devices running. That's because we have 7 Emusim tests running here. You can see all of them are obviously on the same platform. However, you can parameterize them as you want. One thing to keep in mind with emulators and simulators is because they are virtual machines, they actually do take a pretty long time to start up. That's just the nature of Emusim devices, whether it's local, whether it's in a cloud, it doesn't matter. Whenever you spin up one of these devices, they'll take a really long time to start. And so the majority of the test execution time is actually the device starting up, and then a small portion is the test. And so here, for example, you can see we have a test that executed in 47 seconds. The device itself takes a number of seconds to start up, and you can see that the test is actually about to start here at about 40 seconds, right? So the test itself takes about 5 seconds. The rest of the time is the device spinning up. So keep that in mind. This is where parallelization comes into play, because your Emusim test will be the slowest tests out of all of them. And so when you can do massive parallelization, then you can run, 100 2-minute tests in 2 minutes, even though the portion of the test is only like 15 seconds. Let's take a look at iOS Emusim test just so we can compare. Not many differences here. Everything is pretty much the same, except really it's using a different driver. That's pretty much it. The tests continue to look the same, and let's go take a look at some real device tests. Let's switch it up a bit and look at an iOS test over an Android test. So this is a real device. What a real device means is that there's a physical device sitting in a data center, and this device is waiting for automation commands. And so in this case, if we have an iOS device, there is an iPhone 11, iPhone 12 sitting in a data center waiting for our tests to execute. And so in this case, and they do look a little bit different from Emusim tests, so we do kind of have to keep that in mind. If we take a look at the type of configuration we have, we can see here we're looking at the most popular iOS devices. We'll come and take a look at those. And here we are specifying 3 different parameters. We're specifying the iPhone that we want, which is, I'm saying I want any iPhone 11. Here we are saying we're running on iOS, and we are also using the Safari browser. Now this can be also modified to run native applications, in which case we are not setting a browser and then it will open in a native context. If we take a look at the mobile-based test, we can see that we are having a setup that configures our Appium options. And here is us setting our device name, the platform, and the browser. Exactly the 3 parameters that you saw being passed in. And here's that constructor signifying exactly the same thing. And then we have to have a special iOS setup because it does return an iOS driver, and an Android returns an Android driver. And so we get back our special driver, have teardown, which you've seen many times before. And now with all of that said, we can run our test, which again looks very familiar to all of the tests that you have seen. You don't even know that it's on a mobile device versus a desktop device. The functionality of the application is exactly the same, and so these tests continue to look exactly the same. However, the page objects do look a little bit different because it is on native devices. So let's open up this page object and take a look at what that looks like. As I've previously mentioned, it does take an iOS driver, and an Android login and an Android page does take an Android driver. It is using a wait class, and by the way, this is actually used in all of the page objects, something that I do want to quickly talk about. The wait class allows us access to Selenium's expected conditions, and it allows us to basically perform expected conditions and explicit waits on all of our element locators. So for example, if we want to do something like finding a username field, you can see that we're doing wait until is visible, and then afterwards we are performing operations with our device. And so actually this is really important. Explicit waits should be the only types of waits that are used in our applications, And the reason for that is because explicit weights are drastically more stable, and implicit weights actually have an undefined behavior when we start mixing implicit and explicit weights. So why don't we actually go ahead and run these tests so we can see what they look like. So we're going to run it. Just as always, they're going to be parallelized at the class level. That means that we're going to have multiple instances spinning up here in the Sauce Labs cloud. So here in a moment, we're going to have multiple real devices that are going to be executing. You can come here to test results. So see, here we have 4 devices. If we come here to the real devices section, we can see that now we have 4 tests running. You can see that they are running on different devices. And once they are finished, we can actually go ahead and review them. So here is one that executed on an actual physical iPhone 12. And the very first thing to notice here is how fast this test is. So number one, it's 10 seconds. It's exactly the same test as an Emusim test, but it's 10 seconds. The Emusim test, if you remember, was like 46 seconds. So we can open this up, and what you'll see is an actual device here being opened up. We're going to navigate to the URL of our application, and then that's all this test really does. And of course, if it wanted to interact with this web app, it would interact with it just as normal. And you see the commands here just as normal that you can then analyze for different kind of properties and help you with debugging. And just to compare, here's a real device Android web test. Looks very similar to an iOS test. All the main difference is that it has an Android driver over an iOS driver. The rest is extremely similar. The only other piece that I want to point out is our all tests base, which we've been using in every single test class, whether desktop, visual, or mobile. And that looks like this. You can see that it has a driver. It has all of our username and access keys. It has the JavaScript executor, and then it returns a number of different drivers that point to relevant endpoints for the type of service that we are trying to use. All right, everyone. So I hope that you had an amazing time creating a best practices framework that does functional testing on desktop, mobile, and Emusim, and also does visual testing, all using .NET. I've been Nikolai Volodkin. It's been my pleasure, and see you next time.